Hello. Calculus 1. This is a couple examples from Chapter 4, the early sections in Chapter 4. Just some extra examples in addition to what we did in class. So this is 4.1. So this is absolute maximums and minimums. If we're finding absolute maxes and mins, we need to specify some sort of interval. The idea is we'll find the derivative, use that to find the critical points, and then we'll compare the original function value at the critical points versus the endpoints of the interval. The max will either happen at these critical points or the endpoints, the absolute max or min. Let's get to it. First and foremost, we need a first derivative. What I would do in this case, our function is 4 times the root of x minus x. The interval is the closed interval 0 to 9. So I would just rewrite our original function as, right, anytime we see a root, we kind of want to just go on autopilot and write it as x to the positive 1/2. So f of x sort of rewritten would be 4 times x to the 1/2 minus x. That gets us into a place where we can take a derivative, right, because we want to be able to use the power rule. So then this gets us to f prime of x, 4 times 1/2, x to the 1/2 minus 1 would be minus 1/2, minus the derivative of x would just leave us with 1. That f prime of x needs to be cleaned up a little bit, right? So then that would become 4 times 1/2 would be 2. What I'm going to do is I'm going to suggest, because we now have to do algebra with the derivative, we'll simplify a little bit and let's rewrite it, right? The 1/2 means the root. Because it's negative, it means in the denominator. So this is going to become f prime of x is essentially 2 divided by the root of x, right? So x to the negative 1/2 would be 1 over the root of x. 4 and the 1/2 gets us 2, so 2 over root of x minus 1. So that's our f prime. That's what we're going to be working with. So we need critical points where f prime of x is equal to 0, or in this case, we'll have one value where f prime of x does not exist. This is, a rational, it sort of has some fractions in it. It's rational function. And so what I'm going to do is kind of quickly rewrite this again. The idea is, if I want to rewrite this as sort of one big fraction, I'm going to get common denominators. I'd like to rewrite it so that they're both over the root of x. So f prime becomes essentially 2 over the root x minus what would be, root x times root x over here times 1. So 2 over root x minus root x over root x. And so that would be essentially 2 minus the root of x all over 1 square root of x. So that kind of combines these both into one fraction. And that is helpful for counting critical numbers, because what we'll be able to do is just sort of separately say, when is the top equal to 0? 2 minus root of x equals 0. So that would mean for us that 2 is equal to the root of x, which if we then kind of squared both sides to get rid of this square root, we would see pretty quickly that 2 squared is 4 would be sort of critical point number 1. X equals 4. That's in our interval, right, from 0 to 9, the closed interval. So that counts. We'll get a second point when the denominator is 0. So if the bottom is equal to 0, that's pretty quick. That's just directly the root of x is 0, which means that the x itself would be 0. That's in our interval. It's one of the endpoints, so that's a little redundant because we would have checked that value anyway. Nevertheless, we should sort of acknowledge it as a critical point and make sure if this interval was, a little bit more expanded or a little bit different, we weren't overlooking it. A thing I may or may not have done earlier in the day today when I was working with one of you in the tutoring center. Anyway, so how do we find which of these values is our absolute max and which is our absolute min? So what we're going to do is compare into the original f of x, our critical numbers, and our endpoints for the interval. So that for us will be sort of 0 and 4 and 9. So into f of x. So I want f of 0, I would like f of 4, and then f of 9. And so I'm just literally directly just like subbing these in to the original function. So in that case, right, it's 4 times the root of x minus x, 0 and 4 and 9 going in for the x. We're just going to see what we get. So if 0 goes in, 4 times the root of 0 minus 0 is going to be 0 minus 0 is 0. Acknowledged. Right? We got to get all these sort of outputs first to just see which is biggest and which is smallest. When the x value is 4, 4 times root 4 minus 4, just 4 is everything. Root of 4 is 2. 4 times 2 minus 4 would be 8 minus 4 would be positive 4. Okay, so we currently have candidates for sort of smallest and biggest. Let's see what happens when the x value is 9. 4 times root of 9 minus 4, or I'm sorry, no, minus 9, right? I got seeing these 4s from above. Root of 9 is 3, so that's 4 times 3 minus 9. That would be 12 minus 9 is positive 3. So that's sort of a value in the middle. So that endpoint is sort of in between the other two. And so what we can say here to kind of, wrap it up, put a bow on it, f of x has an absolute max value of 4 at x equals 4. Right? So the wording is always like, what is the value that you hit? And then where did that happen? So the max value was 4. We hit it when the x value was also 4. F of x has absolute, that was the max, right? An absolute minimum value. So for us, that will be 0 at x equals 0. So obviously not always will these points be in sync. That was just sort of happening in this one, just in case. If we expanded this interval, if we changed the interval, we would get slightly different answers, and that's fine. So that's all something to consider, right? If this wasn't necessarily just going to sort of finish at 9, in that case, right, we would have a different value to sort of plug in, and we would go from there. We don't have any other critical numbers, so we're not going to get any extra values that way, but we could have a different value instead of 9. If we put in something bigger than 9, what would happen if you sort of think of this original function? In this case, you would hit 0 again at x equals 16. And then if you did an x that was bigger than 16, if you're thinking of things that would square root nicely, 25, 36, 49, 100, yada, 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 those will start to give you negative outputs and then would therefore kind of become the absolute minimum. This is a function that is going to sort of increase from 0 to 4, and then it's just sort of drops from then on. So there we go. An extra 4-1 example, one that's not necessarily just another polynomial, a little bit different. So get a couple things in the mix. I'm going to do a couple 4.3 examples next.